Hey guys, welcome to AI with AI. This side Asif Himdad. In this video, we are going to talk about a really amazing, really interesting, and one of my personal favorite technique in machine learning, that is support vector machine, abbreviated as SVM. Support vector machine is one of the most popular supervised learning algorithm which can be used for both regression and classification tasks, but it is widely used in a classification objective. We're going to talk about this support vector machine. Make sure to watch this video till the end to understand in detail. Let's get started. Support vector machine is not preferred only by me but many machine learning enthusiasts because it produces high accuracy with the less computation power. I guess by now you are well versed with the linear regression and logistic regression algorithm, right? So to understand this support vector machine, you need to understand how linear regression works, how logistic regression works, and we have discussed both these algorithms with the demo in the previous videos. So if you haven't watched those videos, I suggest you to please go and watch the linear regression and logistic regression algorithm videos first. I'll keep the link in the description and I button above. Have a look at them first. Alright, so if you remember from our previous discussions in linear regression, we discussed a simple example, right? Where we have plotted a data for cancer data set here, where we have data of harmless and harmful tumor, right? We have plotted this data against age and the tumor size. So this is how the plot looks like. These are harmless tumors and these are harmful tumors. I know you already know how do I classify this, how do I create a machine learning algorithm for this. It's a very simple classification technique, right? I can use logistic regression. I can just draw a line over these, not over these, but to divide these so that I can have the classes. Simply, I can draw a line like this. It will become a logistic regression. Simple. I can easily classify the data, right? So if any data falling here will be categorized as harmful tumor, and if any data falling here will be categorized as harmless tumor. It is very simple. So we already know about this regression line drawn for classifying data, which is nothing but the logistic regression line here, right? Then how the support vector machine is different than logistic regression? The problem with this kind of training data set is that I can draw a line to classify data in multiple ways, right? I can draw a line like this. I can draw a line like this. I may draw in future a line in between, right? I have a multiple ways by which I can draw a line. Then which is the best line to segregate the data, to classify the data? This is what the question is. And this is where SVM plays a very amazing role in classifying this data, because SVM thinks in future. Currently, we are looking at only training data, right? In future, there are chances that the real data set may be critical and that fall very close to these lines. And in that situations, there are chances we may have a wrong predictions. Let's say if I get the data set somewhere here, look at the pointer somewhere here. If I get the data set here, then chances are that this will be classified as harmless because this falls next to the line, below the line, right? So this will become harmless. But if I look at the data set logically, looking at the age and the different harmful tumors, it is very closer to the harmful ones. In reality, there are high chances that this tumor is harmful, but this is wrongly classified as harmless. So drawing a line like this not be a good, and hence support vector machine comes, and that is why support vector machine comes to a rescue. And support vector machine thinks in future and helps us divide or classify the data in a better way. We all know game of chess, right? Where we think of what will be the next move that will be played by the opponent. So based on the next move, we will play our move. So same way support vector machines thinks what kind of data sets will come in the future. So based on that, it will try to draw the best classification line, right? And that is called large margin classifier, something like this. So it keeps a margin, it draws a margin, something like this, keeping a spaces, then it draws a line exactly at the center. So the best classification line will look something like this. So in simple words, the goal of SVM algorithm is to create the best line or a decision boundary that can segregate n dimension space. So currently it is a line because of 2 dimensions, but in n dimensions, 3 dimensions and more, I will call this as hyperplane. So this line will become hyperplane. In simple words, I can say that support vector machine keeps a margin, something like this, between the data so that it can draw a best classification line. And hence we call this classifier as large margin classifier as well. Support vector machine is also called large margin classifier because it keeps some margin from the line. So this is the actual classification line or a hyperplane in n dimensions, and it has some margin. You see that, right? So we are not drawing a line like this or like this, right? We are keeping some margin and drawing the line exactly in between. These are not the lines. This is just the margin kept to draw this best dividing line here. Let's understand support vector machine in more details. Look at the diagram here in the left side, right? We have a data. Here we have harmless tumors, we have harmful tumors. To divide these kind of data set, I can draw a line something like this. Three ways, right? This way I can draw a line, and I can classify this way I can draw a line, this way I can draw a line. Multiple ways by which I can divide the data. But which hyperplane I should choose is the question in such situations. So that is why logistic regression will have very bad accuracy in these kind of data sets, right? Whereas, as I've told you, support vector machine thinks in future and keeps a margin, draws a best division line, keeping the margin between these data sets so that you get the best accuracy among different any other algorithm. Okay, so how does support vector machine draws a line? Look at this diagram here on the right hand side. So the data set here is exactly same, right? So harmless and harmful tumors. So no difference in the data set. But how does SVM classifies the data in this situation? So the very first thing that support vector machine does is it identifies the extreme point, which are also called as vectors. The extreme point means the points which are critical, right? So you see these points are very closer to the classification line. So this data point, this data point, this data point are nothing but extreme data point, and these are also called as vectors, right? Very important interview questions. What is hyperplane? What are vectors in support vector machine? Vectors are nothing but the extreme data points which are very close to the hyperplane based on which this margin is decided in SVM. So these points are your vectors, and these are nothing but support vectors which helps to draw this margin, and hence the name is support vector machine. So very simple thing that you need to understand here is support vector machine is looking at these supporting vectors, that is extreme points where it can keep the margin. So this is the maximum margin that can be added, and this is the maximum margin that can be added, and based on this margin the actual hyperplane will be drawn, which is nothing but the classification line or hyperplane in n dimension which will be drawn, and this is the margin. And the goal of SVM is most of the time is to maximize the margin. So more the margin is, more the distance is, more the accuracy in real time. While training the algorithm, there are chances that accuracy will be low, but in real life, when you actually provide the real-time data, the accuracy will be improved because it keeps the margin and gives you the better and better division classification of the data, right? Just by visualizing this and looking at this, you will able to understand this. Okay, so just to give you idea, understand this, right? Look at the laser pointer here. So in future, if any new data point comes here, let's say here just next to this red one, which is harmless tumor, but this is that line drawn by the logistic regression. Let's assume this is not support vector machine. Let's say support vector machine is this one. Logistic regression draws just a line, right? So there are chances that logistic regression may draw a line like this. And if it draws a line like this, if any new data comes here in the future, then looking at this classification line, the machine will identify this as harmful tumor. But whereas age is less and tumor size is also small, and which is very closer to these data sets. So just by looking at this data set here in the future which will come, you can easily say that it is not a harmful tumor, it is a harmless tumor, right? But as the line drawn is wrong or there is no margin kept, right? That is why there is a problem, and this is what SVM thinks beforehand and keeps the margin in between and draws a best fitting line by keeping the margin. And hence the goal of support vector machine is to maximize this margin, identify these support vectors, the extreme points, and based on this draw the hyperplane. Beautiful, isn't it? That is why I say support vector machine is so amazing. Let me know in the comment if you understood what I have discussed. Please don't forget to like and subscribe to this channel because lot of new topics, lot of new concepts, lot of new algorithms and demos and examples which will be coming in the near future. Soon I'm also uploading the Git repository link where you can also try these same examples that I have tried. So stay tuned, make sure you subscribe to the channel and also press the bell icon. Alright, so now we understood margin is really important in support vector machine. But what margin? As I've told you, maximizing the margin is important. Let me clarify that with the next slide here. If you look at this, there are two diagrams again. Which one is better? So this one on the left hand side or on the right hand side? Look at the diagram. I'll wait here for a second and think which one will give you the better classification, which one will give you the better accuracy in the future. If you look at the left hand side diagram and I try to draw the smaller margin classifier, this is smaller margin comparative to the right hand side diagram, right? So small margin will have a bad accuracy in the future, because if you look at this one, the vectors, the supporting vectors, this data point and this data point here, because of these data points, the margin is kept like this and hyperplane is drawn something like this. But logically thinking, in reality, I can say that these are ambiguities or these are out of the box or 1 in million, right? So only one data point is very away from the actual data points which are here, right? So in this situation, it is always better to increase the margin. So if you increase the margin, something like this, which we can do by minimizing the value of C, which is nothing but the parameter tuning in machine learning. So when you tune a parameter, when you reduce the value of C, the margin will increase. What do I mean by reducing the value of C? Tuning parameter, we'll see that in the demo. But for now, you just have to understand that the margin needs to be maximum. Though the training accuracy is less, we are okay with that. But in reality and in the test scenarios, in the production, your machine will give you the better accuracy if you have maximum margin classifier. Okay, so data set is same, only the thing is the way we are drawing the line, the way we are drawing the hyperplane is different, and one of the data point that you see here is wrongly classified, but we are okay with that because this is 1 in million, right? This is out of the box. This could be ambiguity, and that is why maximizing margin classifier is okay. Even if training accuracy is less, we are okay with that. We need to have the better accuracy in reality, in the real life, in the production, right? So the conclusion from this discussion is have a maximum margin classifier. Margin classifier is nothing but support vector machines, and these are your supporting vectors in this situation. And this is my hyperplane. Beautiful it is. Okay, so this is the part 1 of the support vector machine video. In the next video, we're gonna talk about more on SVM. I'll discuss about what do you mean by hyperplane. I have been talking about hyperplane again and again. Let's understand that in the next video. Also, what do you mean by vectors? Also, the types of support vector machines. So make sure to watch next video, which is part 2. So that is it for this video. I hope you understood what is support vector machine. If you keep liking these videos and comment on these videos, it will reach to more people, which will eventually motivate me to create more free videos for you guys. Okay, thanks a lot. See you again in the next video. Bye bye.